Welcome back, everyone. Ready for another deep dive. Today, we're getting into something that's got me pretty excited. We're talking about making those big, powerful AI systems we all hear about, the large language models, more efficient
That's right.
without losing any of their smarts.
Yeah. We're diving into the world of quantization, where we kind of shrink these massive models down by using fewer bits to represent their data.
Okay, so fewer bits, smaller model. I'm with you so far.
Exactly. It's like when you zip a file on your computer, right?
Ah, got it.
It takes up less space, but you still have all the information there.
Makes sense. But I got to ask, making things smaller,
Hmm.
there's got to be a trade-off somewhere, isn't there?
Absolutely. With LLMs, there's always this balance we're trying to strike. We want them to be accurate, we want them to use less memory,
Yeah.
and D, we want them to run fast.
Right, like having your cake and eating it too.
Exactly. But these goals, sometimes they kind of clash.
Oh, I see, I see. So, where does this new research MixLLM fit into all of this?
Well, MixLLM is taking this challenge head on and coming up with some really cool new techniques.
Okay, I'm listening.
The problem with a lot of the old ways of doing quantization is that you either lose some accuracy or you slow things down.
A classic dilemma.
Right. Some methods, they're great for memory, but not so much for speed, and others are fast, but maybe not as accurate.
Like picking between a plane and a boat to ship something, right?
Exactly. And MixLLM, they're proposing something different, something smarter.
Okay, I'm intrigued. What's their secret sauce?
What if, instead of treating all the data the same, we prioritize the most important bits?
Now, that's an interesting idea. So how does MixLLM figure out what to prioritize?
It uses this concept called global salience. Think of it like a concert, general admission versus VIP tickets.
Okay, got it.
General admission gets you in the door, but VIPs, they get the best seats, special
I
treatment.
get the royal treat.
Right. So MixLM figures out which output features are the VIPs, the ones that really matter for the model to work well, and it gives them more bits.
So it plays favorites, but for a good reason. Does the paper actually show how much this VIP access varies?
It does. If you look at figure 2 in the paper, you can see that the need for high precision can be totally different depending on which part of the model you're looking at.
Wow, that's fascinating. But I'm curious, how does MixLLM decide how to set things up? Like, what's going on under the hood?
Well, it uses a combination of some pretty clever techniques.
Okay, break it down for me.
For the activations, it uses 8-bit precision, which is a good sweet spot for keeping accuracy high without slowing things down too much.
Makes sense. What about the weights? Don't those usually need more precision?
They actually found they could go down to 4-bit precision for the weights, but they use this thing called asymmetric quantization.
Asymmetric quantization. Okay,
Yeah.
now you're just using big words to impress me.
No, it's actually pretty intuitive.
Mhm.
Imagine a scale that's more sensitive to small changes on one end.
Okay, I'm picturing it.
That's what asymmetric quantization does. It lets us represent small values more precisely.
So they're really squeezing every bit of performance out of those 4 bits. Are there any other tricks up their sleeve?
Oh yeah, there's more. MixLLM also uses group-wise processing for both weights and activations.
Okay, what does that mean?
Think about a pizza. It's easier to eat and digest in slices, right?
I can definitely get behind that analogy.
So group-wise processing breaks down the calculations into smaller chunks.
Divide and conquer.
Exactly.
Mm.
And that actually leads to better results overall.
Okay, I'm following you. But I got to ask, how do they actually USC this 4-bit weight system with GPUs? Don't GPUs usually work with like 8-bit chunks?
Excellent question. They use this clever two-step process called dequantization. It's designed to work seamlessly with those super fast Inte tensor cores that are in GPUs.
So it's like having a translator so everything runs smoothly.
Exactly. And it keeps the extra processing overhead to a minimum.
Wow, they really thought of everything. So we've talked about all these cool techniques, but the real question is, does it actually work? Like, does MixLLM deliver on its promises?
Let's talk results. One of the key things they look at is perplexity.
Perplexity.
It basically measures how well a language model can predict text.
Right, so lower perplexity is better. Right.
Exactly. And what's amazing is that even with just 4.4 bits, MixLM beats out other 4-bit methods and even gets close to the performance of 5-bit quantization.
Impressive. Table 1 in the paper really shows those gains. But perplexity is just one piece of the puzzle. How does MixLM perform on, real-world tasks like answering questions, solving problems, that sort of thing?
Now we're getting to the good stuff.
Lay it on me.
They put MixLLM through its paces on a whole bunch of challenging benchmarks, and the results are consistently good. Question answering, reasoning, you name it.
So it's not just a one-trick pony.
Nope. You can dig into all the details in Table 3 of the paper if you want to see for yourself.
I might just have to do that. This is starting to sound like a pretty big deal. But what about speed? Is it actually faster in practice?
Oh, it's definitely faster. MixLLM consistently beats a standard Float 16 model when it comes to speed.
Really?
Yeah. And they even compared it to some other state-of-the-art methods like TRT-LLM and QOQ, and MixLLM still comes out on top.
That's impressive. Figure 5 in the paper really shows how much faster it is.
It's pretty remarkable.
So MixLLM is accurate, efficient, and fast. Sounds almost too good to be true.
Right?
But I bet we're not the only ones with questions about all this.
I'm sure there are plenty.
Like for starters, how practical is this for real-world use cases?
Well, one of the worries with some of these efficient LLMs is that you need multiple steps to process things, which can slow things down, right?
Yeah, that makes sense.
But with MixLLM, their single pass search method is actually fast enough for practical use.
So no need to wait around for ages.
Nope. You can see the numbers in Table 5 of the paper.
I'll have to check that out. Okay, one more question that's been bugging me. We talked about Figure 2 earlier, the one that showed how some parts of the model need way more precision than others.
Yeah.
Why is that? Like, what's going on there?
That's a great question, and it actually points to this deeper mystery about how these models learn and store information.
Intriguing.
Yeah. Table 4 breaks it down by layer type, and it seems like the vproj and downproj layers, they need a surprising amount of detail.
So those are the VIPs of the model.
It seems that way, but it really makes you wonder, what does that tell us about what they're doing, how they're working? It's something researchers are still trying to figure out.
It's amazing how even when we're trying to simplify these models, we just uncover more questions.
Exactly. It highlights how we're still just scratching the surface of understanding how these complex systems really work.
That's what makes it so exciting, though, right? There's so much more to explore.
Absolutely. And speaking of exploring, the MixLM team is actually making their code open source.
Oh, wow.
Yeah, they're sharing their techniques with the whole AI community.
That's awesome.
Yeah, it's a huge step towards making LLMs more accessible to, well, everyone.
Right, because right now, it's mostly just big companies and research labs with tons of computing power that can really work with these models.
Exactly. But imagine a world where anyone with a decent computer could run a powerful language model.
That would be game-changing. What kind of impact could that have?
Oh, the possibilities are endless. Independent researchers, small businesses, even just individual creators could harness the power of AI in ways we can't even imagine yet.
It's mind-blowing.
Think about it. Personalized education, accessible healthcare, even things like creative writing could all be transformed by this.
It's incredible to think about. So we've covered the problem, the solution, all the technical nitty-gritty, and the potential impact.
You've done a deep dive.
We really have. But let's bring it back to our listeners for a second.
Okay.
Why should they care about all of this?
The bottom line is this. LLMs are becoming more powerful and more accessible at an incredible pace.
It's moving so fast.
It really is. And MixLLM is just one example of the amazing progress that's being made.
And it's not just about the technology itself, right? It's about what this technology allows us to do.
That's the key.
Solving real-world problems, empowering people, pushing the boundaries of human creativity. It's not just about better language models. It's about a future where AI can truly help us reach our full potential.
I couldn't have said it better myself. And that future is closer than we might think.
I'm excited to see where it all goes. For our listeners who want to get into the nitty-gritty details, definitely check out the full MixLLM paper. It's full of fascinating stuff.
Yeah, it's a great read.
And we want to hear from you. What stood out to you in this discussion? What questions are you left with? Share your aha moments with us on social media or on our website.
We love hearing your thoughts.
Because the more we all understand about how these models work, the better equipped we'll be to use them responsibly and ethically.
Absolutely. And you know, the fact that different parts of a language model need such different levels of precision, it really raises some interesting questions.
Doesn't it?
Like, if some parts can function perfectly fine with very little information, while others need a ton of detail, what does that tell us about how the whole thing is learning?
It makes you wonder.
It does. So here's a thought. Could this lead to even more specialized quantization techniques?
Ooh, interesting.
Like, instead of a one-size-fits-all approach, What if we had different tools that were perfectly designed for different types of data within the model?
That would be amazing.
Right. We could potentially get even better efficiency and performance by moving beyond this idea of global salience and really understanding how each part of the model learns and processes information.
So MixLLM isn't just a breakthrough in itself, it's a stepping stone to a whole new era of AI research.
It's a game changer. It's a reminder that we're just at the beginning of this incredible journey, and there are so many more amazing discoveries waiting to be made.
Well, on that note, I think we've reached the end of our deep dive into the world of MixLLM and efficient LLMs.
Time flies when you're having fun exploring AI.
It really does. A
Right.
huge thank you to our expert for taking us on this journey.
It was my pleasure. Always happy to share these exciting developments with such an engaged audience.
And to all of you listening, thank you for joining us. We hope you learned something new today and maybe even came away with a sense of wonder about the future of AI.
Remember, this is just the beginning. The world of AI is constantly changing. There's always more to learn, more to question, and more to discover. So keep exploring, keep diving deep, and until next time, keep those aha moments coming.
It's like we zoomed in on this one really cool technique, and it's opened up this whole new world of questions about how AI actually works.
It really shows you that we're only starting to understand how complex these systems are.
It's pretty mind-blowing.
But that's what makes this field so exciting, right?
Yeah, absolutely. And for everyone listening, what are some of the things that you're taking away from this deep dive? Like, does it change how you think about the AI you're using every day?
I hope it makes you think about all the potential that's still out there.
Yeah.
Imagine running these powerful AI assistants right on your phone.
Right.
Or giving researchers in parts of the world that don't have access to all these fancy computers,
Yeah.
giving them access to these cutting edge models.
That would be incredible.
That's the kind of future that this technology could bring.
It's really exciting to think about all the possibilities.
Yeah.
But of course, with any powerful technology, we have to think about the ethical side of things too.
That's a really important point.
Right.
As LLMs become more common and integrated into our lives,
Yeah.
we got to make sure that they're being used responsibly and ethically.
Right, for good.
We need to be aware of things like bias, and protect for people's privacy, and just make sure that these systems are being used to help people, not hurt them.
It's a good reminder that, as technology advances, we need to be having these conversations about its impact on society.
Exactly. And I think these kinds of open discussions are really important to raise awareness and make sure we're all on the same page about using AI for the benefit of humanity.
I think that's a great point. And on that note, I think it's time to wrap up our deep dive into the world of MixLLM and efficient LLMs.
Has it really been that long already?
I know, right? Time flies when you're having fun with AI. A huge thank you to our expert for guiding us through this amazing journey.
Oh, it was my pleasure. Always a joy to share these breakthroughs with an audience that's so enthusiastic about AI.
Absolutely. And to everyone listening, thank you for joining us. We hope you learned something new today and maybe even came away with a sense of wonder about the future of artificial intelligence.
Remember, this is just the beginning.
Yeah.
The world of AI is constantly evolving. There's always more to learn, more to question, and more to discover. So keep exploring, keep diving deep, and until next time, keep those aha moments coming.